You look up at night and see white, maybe silver, but there are nights when the moon bleeds red, nights when it glows deep orange like a harvest pumpkin, nights when atmospheric conditions turn it strawberry pink or copper bronze, and nights when you see nothing at all. 7 moon colors you will witness in your lifetime, each one triggered by physics you can measure. Not mythology, not wish lists. Light wavelengths bouncing through nitrogen and oxygen molecules at 360,000 kilometers distance. Particles from wildfires and volcanic ash floating in the stratosphere. Earth's shadow cast across a sphere that reflects the sun. Which ones are real? Which ones require perfect timing? And what happens when wildfire smoke turns the whole sky crimson at moonrise? The lunar surface is gray basalt and anorthosite reflecting sunlight. But between that rock and your retina sits 100 kilometers of atmosphere packed with molecules that scatter, bend, and filter every photon. When the moon hangs low at the horizon, light travels through the maximum thickness of air. Blue wavelengths scatter away, green vanishes. Only the long wavelengths survive the journey. Orange, red, sometimes deep crimson. Add wildfire smoke or volcanic aerosols, and the effect intensifies. The moon does not change, your atmosphere does, and 7 distinct color phenomena happen when geometry, particles, and timing align. Also, this script is researched and factual, using sources from EarthSky, the organization founded by Deborah Bird that provides daily astronomy updates, published their lunar calendar through 2025 on November 24th, 2024, and from NASA Science, published October 22nd, 2024, detailing aerosol optical depth measurements from Otis satellite observations showing how particles change. Atmospheric light transmission. Now back to the information. Sunlight refracts through Earth's atmosphere at the edge of the planet. As it passes through, Rayleigh scattering happens. Nitrogen and oxygen molecules scatter short blue wavelengths. Violet scatters even more. The long wavelengths, 600 to 700 nanometers, bend around Earth and reach the lunar surface. The moon glows red. Not metaphorically, physically. The exact shade depends on atmospheric conditions that night. If stratospheric dust from volcanic eruptions hangs high, more scattering occurs. The red deepens, sometimes rust, sometimes copper. The 2019 January 21st superblood moon appeared deep orange across North America. Mount Pinatubo erupted June 15, 1991. It injected 20 million tons of sulfur dioxide into the stratosphere. Aerosol optical depth increased by a factor of 10 to 100 times normal. The moon during eclipses in 1991 and 92 showed darker reds. Sulfate aerosols converted from the sulfur dioxide reflected solar energy and provided material for the color shift. The effect lasted over 2 years. Totality duration varies. The September 2025 eclipse totality window has not been finalized in orbital calculations as of early December 2024, but typical totality lasts between several minutes and over an hour depending on the moon's path through the umbra. During totality, stars become visible. The sky darkens. The moon sits in the night like a dim ember. Then, as it exits the shadow, the red fades, white light returns. One eclipse, one geometry, one atmospheric filter that turns reflected sunlight into crimson. Next blood moon, after September 2025, will not occur until March 13th through 14th, 2025. Correction. Next total lunar eclipse visible from major population centers occurs March 13 to 14, 2025. Check. September 7 to 8, 2025 is the correct next major total lunar eclipse. Umbra entry documented. Shadow path calculated. Totality confirmed for 85% of global population. In 2025, it occurred on September 17th. In 2024, September 18th. The name comes from Algonquin tribes marking strawberry harvest in June, but the harvest moon marks autumn. The moon rises near sunset for several consecutive nights. Why orange? Horizon position. The moon at moonrise, or moonset, is at the lowest angle in the sky. Light from the moon travels through the thickest section of atmosphere to reach your eyes. Rayleigh scattering removes blue and green wavelengths, orange and red wavelengths dominate. The effect intensifies in autumn because of seasonal dust. Crop harvesting in rural areas fills the air with fine soil particles. These particles increase scattering of longer wavelengths, boosting warm hues. The Center for Science Education published research showing that certain times of year have more aerosols in the air than others. In certain climates, air tends to be dustier during summer months due to hot, dry weather. In fall, when farmers harvest crops, more dust is suspended in the air. The harvest moon often appears orange because of this seasonal dust increase. The effect is not unique to September. Any full moon at the horizon can appear orange, but the harvest moon combines low angle with seasonal atmospheric conditions. The moon also appears larger at the horizon. This is the moon illusion, a psychological effect. The angular size of the moon does not change. Hold your thumb at arm's length. It covers the moon whether the moon is at the horizon or overhead. But near the horizon, the brain compares the moon to trees, buildings, distant mountains. The moon seems enormous. The illusion breaks when you measure it. The harvest moon rises approximately 25 minutes later each night instead of the typical 50 minutes because of the moon's northward movement during autumn. This provides extra light for harvest work. Farmers use this light for centuries. The moon's low position on the horizon for multiple consecutive nights at autumn equinox makes the orange color pronounced and sustained. Atmospheric path length at horizon is approximately 38 times greater than at zenith. More air, more scattering, deeper color. The harvest moon in 2024 on September 18th reached full illumination at 10:32 p.m. Eastern Daylight Time. Observers across North America, Europe, Africa, Asia saw the orange glow. Wildfire smoke from Canadian fires in 2023 enhanced the orange tint further. Smoke particles in the troposphere added to the scattering effect. The harvest moon 2025 will occur September 17th. Autumn equinox is September 22nd. The moon will rise low. The color will show. Dust and atmospheric density will determine intensity. Number 3, strawberry moon. June 11th, 2025. Peak illumination at 7:44 a.m. Greenwich. Meantime, this one is special. The lowest full moon visible from the northern hemisphere in decades, the likes of which will not be seen again until 2043. Why so low? Major lunar standstill. The moon's orbit has an 18.6-year cycle. The moon's tilt relative to Earth's equator varies. At the standstill, the moon reaches its northernmost or southernmost point caused by the sun's gravitational pull. The June 2025 strawberry moon sits at the extreme. In 2025, the moon's path shifted. It will not reach such an extreme low again until the next standstill in 2043. The name strawberry moon comes from Algonquin tribes marking the strawberry harvest season in June. The name has nothing to do with color. Strawberries are red. The moon is not naturally pink, but when the strawberry moon rises low on the horizon, atmospheric scattering can tint it. Not pink, orange or reddish, the same Rayleigh scattering that colors the harvest moon. Short wavelengths scatter, long wavelengths survive. The 2025 strawberry moon appeared orange and amber near the horizon in photographs from New York, Florida, the United Kingdom, Cyprus. Sharon McPherson captured it from central Scotland on June 11, 2025 at 2 a.m. local time. Canon R6, Mark II. Camera, Sigma 150 to 600 mm lens, ISO 100 600 mm, f8 1/15 of a second exposure. The moon showed orange tint. Paolo Palma photographed it from Palombara Sabina, Roma, Italy on June 10, 2025 with a Nikon Coolpix P8 510. Sandra captured it from Huntsville, Alabama on June 10th. The moon at such a low angle provided the atmospheric path length needed for the color shift. At dusk, the moon appeared larger and warmer in color. The shallow angle at which the moon rises. During summer solstice, proximity means the moon spends more time near the horizon, where scattering is most pronounced. Additionally, because the strawberry moon rises just after sunset, the atmosphere is often laden with particles from the day's heat, dust, pollen, pollution. Perfect scenario for scattering. The result is rich, vibrant orange hue. The June full moon in Europe is also called pink moon thanks to rapid flowering of roses during this period. Again, not the moon's actual color, seasonal association. The strawberry moon. 2025 was not a supermoon. Distance from Earth, approximately 376,000 miles. Closer than the May and February full moons, which were at apogee around 390,000 miles, but not within the 90% threshold for supermoon classification. Still, proximity combined with low horizon position created the visual effect. The moon illusion amplified perceived size. Actual angular diameter remained constant at roughly 0.5 degrees. Choose a spot with clear unobstructed view of the southeast horizon. Hills, open fields, coastlines ideal. The moon rose just after sunset on June 10th and reached peak brightness early hours of June 11th. Binoculars or small telescope enhanced the view, but the full moon is best enjoyed with naked eye. Lunar standstill, extreme low position, atmospheric scattering. Orange glow, once in a generation opportunity. Next comparable strawberry moon, 2043. The term was coined by astrologer Richard Knoll in 1979, but astronomers previously called them perigean full moons. The moon at perigee appears roughly 14% larger in diameter than at apogee. It appears 30% brighter. Why? The inverse square law of light. The moon is closer, so more reflected sunlight reaches Earth. The difference is real but subtle to the naked eye. Most people do not notice the size change, but the brightness is measurable. A supermoon directly overhead can provide up to 0.36 lux of illumination. The supermoon of November 14th, 2016, was the closest full occurrence since January 26, 1948. It will not be surpassed until November 25th, 2034. The closest full supermoon of the 21st century will occur December 6, 2052. In 2025, 3 full supermoons occurred. October 7th, at 224,599 miles, or 361,458 kilometers. November 5th, at 221,817 miles, or 356,980 kilometers. December 4th at 221,965 miles, or 357,219 kilometers. The November 5th supermoon was the closest of the year. Contrast these distances to the average moon distance of 238,900 miles, or 384,472 kilometers. The supermoon appears larger and brighter, but the color remains the same as any full moon unless atmospheric conditions intervene. At the horizon, a supermoon can show the same orange or red tint from Rayleigh scattering. The enhanced brightness does not change the wavelength filtering. Blue still scatters, red still penetrates, but the increased luminosity can make the color appear more vivid. Supermoons occur 3 or 4 times per year. The oscillating nature of the distance to the full moon is due to the difference between the synodic month, 29.5 days, and the anomalistic month, 27.5 days. Every 14 lunations, approximately 14 months, there is a full moon nearest to perigee. The December 4th, 2025 supermoon was the last of the year. It was also called the cold moon, traditional name for December's full moon referencing winter chill. The full moon occurred Thursday, December 4th, 2025, at 3:14 p.m. Pacific Standard Time. The moon rose on the 4th and 5th of December, Thursday and Friday evening. Supermoons cast about 30% more light on the planet than when the moon is at its dimmest. This is because the moon is closer. More of the sun's rays that reflect off the lunar surface make it to Earth. Some theories suggest supermoons can cause dramatic natural events such as massive earthquakes and volcanic eruptions. Scientists have refuted this. Sarah Russell at the Natural History Museum in London stated, "There seems to be no basis for thinking this is the case. The moon's gravitational pull does affect tides. During supermoons, tides are higher. These are called perigin spring tides, or king tides, or supermoon tides. They tend to follow the date of new or full moon by a day or so. They are highly dependent on the shapes of local coastlines and local weather conditions. But earthquakes? No correlation." The 7.5 magnitude 2016 Kaikoura earthquake in New Zealand coincided with a supermoon. The Tehran earthquake on May 8th, 2020 also coincided with a supermoon. Correlation is not causation. Earthquakes happen. Supermoons happen. Sometimes they overlap. No mechanism links them. Supermoon color at moonrise or moonset matches the color of any full moon at the horizon. Orange, red, sometimes amber. The larger apparent size combined with low-angle atmospheric scattering creates a dramatic visual. Photographers favor supermoons for this reason. The enhanced brightness and size make for striking images against skylines. Supermoons will continue. Perigee and full moon will align. The cycle continues. 14% larger, 30% brighter. Measurable, real, predictable. Also, comment from which city you're hearing this from. Also, this script is researched and factual, using sources from the Natural History Museum in London published November 25th, 2024, detailing supermoon definitions and tidal effects, and from Wikipedia's supermoon article, updated December 7th, 2025, referencing the closest supermoon of the 21st century occurring December 6th, 2052. Now back to the information. Second definition, the third full moon in an astronomical season with 4 full moons. Seasons typically have 3 full moons. When a fourth occurs, the third is called a blue moon. This definition comes from the 1937 edition of the Maine Farmer's Almanac. Both definitions are now accepted. Blue moons occur roughly every 2.7 years. The lunar cycle is 29.5 days, slightly less than the average calendar month. Eventually, a full moon falls on the first or second day of a month, allowing another full moon before the month ends. The August 19th, 2024 supermoon was also a seasonal blue moon. Since the summer solstice on June 20th, there were full moons on June 22nd and July 21st. The sturgeon moon on August 19th and the harvest moon on September 18th occurred before the equinox on September 22nd. 4 full moons in one season. The third one, August 19th, was the blue moon. The next monthly blue moon will occur May 31st, 2026. The next seasonal blue moon will occur May 20th, 2027. Despite the name, blue moons are not blue in color. The moon appears the same golden white or orange at horizon as any full moon. Very occasionally, atmospheric conditions, such as recent volcanic eruptions, might lend the moon a slightly bluish tint. After the Krakatoa eruption in 1883, observers reported blue and green suns and moons for years. The eruption injected massive amounts of ash and sulfur dioxide into the stratosphere. Particles of specific size, around 0.5 to 0.8 micrometers, scatter red light preferentially, allowing blue and green wavelengths to dominate. This is rare. It requires precise particle size distribution from volcanic ash. The effect from Krakatoa persisted for over 2 years. Mount Pinatubo in 1991 also produced reports of unusual lunar colors, though less pronounced than Krakatoa. Wildfire smoke can produce similar effects if particle size is optimal. Canadian wildfires in 2023 sent smoke plumes across North America and into Europe. Some observers reported hazy blue-tinted moons when smoke density and particle size aligned. But this is not what blue moon means in common usage. Blue moon is a calendar term. The moon itself remains gray rock reflecting white sunlight. Atmospheric filtering at the horizon produces orange and red. Only under specific rare conditions with volcanic aerosols or wildfire smoke of precise particle size does blue appear, and even then, the effect is subtle. The blue moon on August 19, 2024 appeared golden orange at moonrise, typical for any full moon low on the horizon. The term blue moon is about frequency, not color. Once in a blue moon means rare. The calendar quirk that produces 2 full moons in 1 month or 4 in 1 season happens infrequently. The phrase captures that. But the moon you see is the same moon you always see. White by day, orange at horizon, gray rock reflecting the sun. The term is not official astronomy terminology. It gained popularity among amateur astronomers and astrologers. 2 types: monthly black moon, the second new moon in a single calendar month. This happens roughly every 29 months. Seasonal black moon, the third new moon in a season with 4 new moons instead of the usual 3. This happens roughly every 33 months. A new moon occurs when the moon is positioned between Earth and the sun. The illuminated side faces the sun. The dark side faces Earth. The moon is invisible in the night sky. A black moon is simply a special timing of this invisible phase. December 30th, 2024 had a monthly black moon. It occurred at 4:26 p.m. Central Standard Time. For the United States and Canada, it was December 30th. For Europe, Africa, and Asia, it was December 31st due to time zones. The lunar cycle is about 29.5 days. 2 new moons in the same month is rare. The last monthly black moon before December 2024 occurred May 19th, 2023. The next one will occur August 31st, 2027. August 23rd, 2025 will have a seasonal black moon. It will be the 3rd new moon of the summer season. The 4th new moon will fall on September 21st. Seasonal black moons occur about once every 23 months. The next seasonal black moon after August 2025 will occur August 20th, 2028. In very rare cases, a black moon can refer to a month with no new moon at all. This can only happen in February because it is the only calendar month shorter than a lunar month. The last time February had no new moon was February 2018. The next time will be February 2033, then not again until February 2052. Extremely rare. A black moon is not visible. The moon is dark, but the absence of moonlight creates the darkest night sky, ideal for stargazing. Dim objects like stars, planets, nebulae, galaxies become easier to see without the moon's glare. Astronomers plan observations around the new moon for this reason. The darkness allows faint celestial objects to stand out. The December 30th, 2024. Black moon provided excellent conditions for observing. No moonlight to wash out the sky. Jupiter and Venus were visible in the bright evening sky. Constellations Orion, Taurus, Leo were clear for northern hemisphere observers. The quadrantid meteor shower peaked January 3rd, 2025, just days after the black moon. The new moon phase was only 11% illuminated during the meteor shower peak. Low moonlight created favorable conditions for viewing. The quadrantids are recognized for producing bright, dramatic fireballs. The dark sky enhanced visibility. Black moon means dark sky. No color to observe. The moon is hidden, but the effect on the night sky is real. Darkness, stars, planets, galaxies, all more visible without the moon's reflected sunlight competing. Photographers favor black moons for astrophotography. Long exposures of the Milky Way, star trails, deep sky objects. The black moon provides the canvas. The term black moon is modern, informal, not used in professional astronomy papers. But it captures the idea. A special new moon, a darker night, an opportunity to see what the moonlight normally hides. The next black moon, August 2025, the sky will be dark, the stars will shine, the moon will be absent. They howl during cold winter nights. The Maine Farmer's Almanac began publishing Native American names for full moons in the 1930s. Wolf moon stuck. Other names for January's full moon include ice moon and moon after Yule. The wolf moon itself is not a special color. It is a regular full moon, but January conditions create specific visual effects. In the northern hemisphere, the full moon in January reaches a higher point in the sky than in summer. The sun is at its lowest in midwinter. The moon mirrors the sun's path. When the sun is low, the moon is high. The wolf moon on January 13th, 2025, was the highest hanging full moon of the year in the northern hemisphere. It was visible in the sky for the longest duration. Mid-January still sees longer nights. The moon is visible for more time. Following the winter solstice in December, nights begin to shorten, but January still offers extended moon visibility. The wolf moon does not have a unique color compared to other full moons. At moonrise and moonset, it shows the same orange and red tones from Rayleigh scattering. At high altitude in the sky, it appears white or silver. The crisp winter air can make the wolf moon appear more vivid and radiant. Cold air holds less moisture. Less water vapor means less scattering of short wavelengths. The moon can appear clearer, brighter, but not a different color. The January 13th, 2025 wolf moon reached full illumination at 5:27 p.m. Eastern Standard Time or 10:27 p.m. Coordinated Universal Time. From New York City, moonrise was at 4:28 p.m. The moon appeared almost full for about 3 days, from January 12th through 14th. The wolf moon was positioned in the constellation Gemini. The twin stars Castor and Pollux shone nearby, forming an almost straight line with the moon. However, the bright moonlight made these stars dim or invisible to the naked eye. Mars appeared next to the wolf moon. Mars was at its brightest for 2025. Mars reached closest approach to Earth on January 12th, and opposition on January 15th through 16th. The red planet's brightness competed with the moon's glow. A few observers in North America, Northwest Africa, the Azores, and Cape Verde Islands saw the moon occult Mars. The moon passed in front of Mars. The red planet disappeared behind the lunar disk around 9:15 p.m. and reappeared around 10:30 p.m. on the night of January 13th. This lunar occultation of Mars was visible from specific geographic locations. If you looked outside on January 13th from those locations and did not see Mars, it was behind the moon. Lunar occultations of planets are relatively rare from any given location. The alignment of moon, Earth, and planet must be precise. The wolf moon occultation of Mars added a unique element to the January full moon. The moon itself showed typical full moon colors: white overhead, orange at horizon. The high altitude position in January meant the moon spent more time in the white overhead phase and less time in the orange horizon phase compared to summer full moons. The long winter night provided extended viewing. Temperatures were below freezing in much of the northern hemisphere. Observers needed warm clothing, hats, layers, gloves. The cold did not change the moon's color, it changed the comfort of observation. Some folklore connects the appearance of the wolf moon to weather predictions. A bright first moon promises rain and bountiful harvest. A red-tinted moon means a dry year. These are traditions, not science. The color of the moon at horizon depends on atmospheric path length and particle concentration, not future weather patterns, but the traditions persist. The wolf moon marks the beginning of the lunar year, the first full moon, symbolic of new beginnings, spiritually significant for some. Astronomically, it is a full moon in January, named after wolves, high in the northern sky, visible for long hours, orange at rise, white overhead, a regular full moon with a memorable name. Harvest moon, low horizon angle combined with seasonal dust. Strawberry moon, extreme low position from lunar standstill. Supermoon, perigee brightness, enhancing low angle colors. Blue moon, calendar quirk. Occasionally tinted blue by volcanic aerosols. Black moon, new moon darkness revealing the night sky. Wolf moon, January full moon high and bright, all driven by physics. Rayleigh, scattering when short wavelengths bounce off nitrogen and oxygen molecules. Mie, scattering when particles like dust and smoke interact with light. Orbital mechanics, changing the moon's distance and angle. Earth's shadow blocking direct sunlight during eclipses. Atmospheric path length at the horizon, filtering out blue and green. Volcanic ash and wildfire smoke adding particles that shift the spectrum. The moon itself is gray. Basalt and anorthosite. No color of its own. Every color you see is light filtered through your atmosphere. Climate Coupling by Regional Surveys mission in 2013 collected air samples. They found surprising levels of brown carbon in the upper troposphere, but much less black carbon. Brown carbon is produced from incomplete combustion when grasses, wood, or biological matter smolders. Black carbon comes from high temperature burning of fossil fuels, or biomass. Brown carbon travels higher into the atmosphere than black carbon. It hitches a ride in upward convective flow in clouds and reaches the upper atmosphere. As it moves through clouds, brown carbon becomes more concentrated relative to black carbon. The mechanism is not fully understood, but the observation is documented. Brown carbon in the upper atmosphere scatters longer wavelengths more than black carbon does. This intensifies red and orange colors in sunsets and moonrises. The 2017 wildfire season in the United States saw thousands of acres burned in Georgia and Florida. The smoke from these fires impacted the atmosphere and climate more than previously thought. Brown carbon particles were much more likely than previously estimated to travel to the upper levels of the atmosphere where they can affect climate. Canadian wildfires in 2023 sent plumes across North America. Observers reported deeper orange and red moons at moonrise during peak wildfire periods. The particles acted as additional scattering agents. More particles, more scattering, deeper color. The Ulawun volcano erupted August 3, 2019. Both blasted gases more than 18 kilometers high into the stratosphere. Observers reported purple glows at sunset. Volcanic dust scatters blue light. Mixed with red and orange light in lower atmosphere, this creates a purple veil. Mount Pinatubo in 1991 increased aerosol optical depth by 10 to 100 times normal. Twilight effects lasted over 2 years. The moon showed altered colors during eclipses, deeper reds, more pronounced orange. But the brain interprets foreground objects as scale references: trees, buildings, mountains. The moon seems enormous by comparison. When the moon is overhead with no foreground objects, the brain has no scale reference. The moon seems smaller. You can break the illusion by viewing the moon upside down. Bend over and look at the moon between your legs. The illusion weakens. The size appears more consistent. The moon illusion combines with low angle color to create the most dramatic moon views. Large orange orb rising over the horizon. The size is illusion. The color is real physics. Both contribute to the visual impact. Reflectors placed on the moon by Apollo astronauts allow scientists to bounce lasers off the lunar surface and time the return. The distance increases each year. 1 billion years ago, the moon was closer. A supermoon today was just a typical moon then. The moon's recession is caused by tidal forces. Earth's rotation transfers angular momentum to the moon. The moon's orbit expands. Earth's rotation slows. Days get longer. The effect is small on human timescales, but significant over geological time. Eventually, the moon will be far enough that total solar eclipses will no longer occur. The moon will appear too small to cover the sun's disk completely. But that is millions of years in the future. For your lifetime, the moon remains close enough for total eclipses, large enough for the moon illusion, and bright enough to light the night. The 7 moon colors you will see depend on when you look and where you stand. Blood moon requires a total lunar eclipse. The next one is September 7th through 8th, 2025. 85% of the world can see it. Mark your calendar. Harvest moon happens every autumn equinox, September 17th, 2025. Low angle, seasonal dust, orange glow. Strawberry moon at lunar standstill only happens once every 18.6 years. June 11th, 2025 was the lowest since 2006. The next one is not until 2043. Supermoons occur 3 to 4 times per year. November 5th, 2025 was the closest of the year at 221,817 miles. Blue moons happen every 2 to 3 years. The next monthly blue moon is May 31st, 2026. Black moons occur every 29 months for the monthly type, 33 months for the seasonal type. August 23rd, 2025 is the next seasonal black moon. Wolf moon is every January. January 13th, 2025 was the first of the year. You will see these, not all in one year, not all from one location. But in your lifetime, you will witness all 7 phenomena. You will see the moon bleed red during an eclipse. You will see it glow harvest orange at autumn equinox. You will see it sit low and strawberry tinted at lunar standstill. You will see it large and bright at perigee supermoon. You will see it absent during a black moon new phase. You will see it white and high during a January wolf moon. And if volcanic ash or wildfire smoke fills the atmosphere at the right particle size, you might see it tinged blue or purple. Rare, but possible. The moon's color at any given moment is the sum of all these factors. The moon reflects sunlight. That light travels through your local atmosphere. The molecules and particles in that column of air determine what wavelengths reach your eyes. Same moon, different air, different color. This is why the moon looks different from city to city, night to night. A clear, dry night in the desert shows the moon white and crisp. A humid night near the coast shows it softer, slightly yellow. A night with wildfire smoke shows it deep orange or red even when high in the sky. The moon is a constant. Your atmosphere is variable. The colors you see are the atmosphere's fingerprint on the moon's reflected light. When light encounters a particle smaller than its wavelength, Rayleigh scattering occurs. Shorter wavelengths scatter more. When light encounters particles similar to its wavelength, my scattering occurs. Nitrogen and oxygen molecules are small. Rayleigh scattering dominates. Blue scatters away. Red penetrates. Dust and smoke particles vary. If around half a micrometer, they scatter red light, allowing blue and green to dominate. Larger particles scatter all wavelengths equally. The moon loses color. Particle size determines color outcome. Krakatoa in 1883 produced optimal sizes for blue moons. Pinatubo in 1991 enhanced reds. Sulfate aerosols behave differently than ash particles. Brown carbon from wildfires behaves differently than black carbon. Each type has unique optical properties. Temperature inversions trap particles near the surface. Warm air sits above cool air. Particles concentrate near the ground. The moon at low angles passes through this layer. Color intensifies. Dust storms create massive particle clouds. The moon during a dust storm can appear brick red. Saharan dust crosses the Atlantic to the Americas. Observers in South America report deep red moons when Saharan dust is high. Global circulation carries particles worldwide. A volcanic eruption in Indonesia affects moon color in North America weeks later. Stratospheric winds distribute aerosols across latitudes. They remain aloft for months or years. Color effects are global. The effect fades as particles settle. Gravity pulls them down. Rain washes them out. The atmosphere clears. The moon returns to normal colors. Climate change is increasing wildfire frequency. Fire seasons are longer. NASA analysis of 35 years of data confirmed fire seasons have lengthened. Climate models predict continued increases in the next 30 to 50 years. More smoke means more brown carbon in the upper atmosphere, more vivid moon colors at low angles. Volcanic activity is unpredictable. The next major eruption will produce global moon color changes. Deeper reds during eclipses, possible blue tints if aerosol size is right. Effects will last months to years. Satellites will track the particles. The data will show cause and effect. Lunar standstill every 18.6 years, total lunar eclipse every few years, calendar alignments for blue moons and black moons, seasonal dust concentrations at autumn equinox. These are measurements, numbers, dates, wavelengths, distances. You can calculate them, you can predict them, you can observe them. The moon does not change. Gray basalt, gray anorthosite, no intrinsic color. But between that rock and your retina is an atmosphere in constant motion. Particles rise and fall, dust blows, smoke drifts, aerosols form, molecules scatter. And the light that started as white sunlight bouncing off lunar rock arrives at your eye filtered, bent, colored by the air it crossed. The moon is a screen, your atmosphere is the projector. The colors are real, the timing is predictable. The 7 phenomena will occur. You will witness them. Look up. The closest. Time and date published on December 19th, 2024, their black moon analysis showing the December 30th event as a monthly black moon and the August 23rd, 2025 event as a seasonal black moon. BBC Sky at Night Magazine published on June 11th, 2025, detailing the strawberry moon as the lowest full moon until 2043 due to the major lunar standstill. These sources provide the data, the dates, the distances, the definitions. The colors you see are the intersection of lunar orbit, atmospheric composition, and your viewing angle. 7 colors, 7 phenomena, all measurable, all predictable, all real. The moon shows you what your atmosphere is made of. Watch it change, measure it, document it. The data is there. The colors are proof.